What's up, YouTubers? So I wanted to do this video as a separate video to all my other 6010 videos that are out or coming out. And the reason being is that people who search on YouTube, why won't 6010 work, or any kind of troubleshooting tips, hopefully this video will pop up for them and they can understand what's going on. So what we're going to cover today is why inverter welders commonly won't run 6010. So we have two stick-capable welders, the little guy here, inverter welder, the Miller Dynasty, also an inverter welder. One of these will run 6010, the other one won't. And in this video, I'm going to explain why and what the solution is to fix that. So let's get into it. So maybe you're finding this video because you're struggling to get 6010 to work, or maybe you're just watching it to gain more knowledge along with all my other videos. And if that's the case, thanks anyways for sticking around and watching stuff. One of the most confusing things that I ran into when I started buying stick welders and learning to stick weld is that I had a couple welders that would run 6010 and some that wouldn't. And when I was in school learning to stick weld years ago, their welders all ran 6010, and that was part of the curriculum for the few classes I took. But when I got to the real world and bought a welder, it wouldn't. And I spent time researching it and it just didn't make sense. And that's why I'm doing this video, is just to knock the dust off of what's going on here. So if you look here, let me bring it up to camera. This says 6010, it says 40 to 70 amps. This is smaller diameter, 332. It says AC or DC EP. I find that interesting that it says AC because 6010 isn't commonly capable of running AC, but this particular rod may run on AC. That's not like these 6010s. These, which it's going to be pretty hard for you to see it, but are DCEP or DCEN only, okay? Well, what they know where on the packaging do they specify, or like on this chart, 6010 EP, you know, well, that also covers 6011, but nowhere does it say that may not work on your welder. So you probably bought some of these, started welding, and then the arc just cuts off, like just completely, like almost like you turned your welder off, and then you restart the rod. It might run an inch or inch and a half, and it cuts out again. Watch this video to see what I'm talking about the arc cutting out. This is probably similar to what you're experiencing. So what's going on is these rods operate at a higher arc voltage than like your 6013, 7014, 7018 rods and so on. Because they need higher arc voltage to keep the arc lit, inverter welders that cannot produce high closed circuit voltage will not be able to run these. And I'm going to show you the signs and symptoms that your welder simply can't run it shortly. And that will kind of explain it. And then we're going to go into depth a little bit, book learning on why the welder probably can't. So let me get some plates set up and start the welders up, and we'll get to welding and see what happens. So the first reason your stick welder might not run 6010 is that what they call the open circuit voltage. So that's the voltage that's present when you're not welding. So the stinger's not making contact through a rod with a plate, so no welding going on. If your open circuit voltage is only, say, 28 or 30 volts, like I found on some cheaper and even some expensive inverter welders, you're never going to be able to run 6010. 6010 on an 1/8 inch rod needs around 30 volts minimum to run. Well, if the highest voltage your welder's can output is only like 28, well, you're never going to run 6010. So in the case of this machine, 78 volts is what the open circuit voltage is. That means right off the bat, we know that this is good enough to run 6010 just based on that, but it doesn't mean it'll run it. So let me show you this red welder here. All right, so I got the probes and the ground clamp and the stinger, and you can see the open circuit voltage of this guy is pretty high, 81 volts. So the voltage on open circuit is high enough to where in theory it may run 6010, but what also matters is what the closed circuit voltage is. So once you actually start welding and you have an arc gap, you need to be able to maintain above 30 volts in order to actually weld with 6010. And that's what we're actually going to look at next. So I'm going to run a couple test welds with the Dynasty just to show you what the voltage 6010 operates at, and then we're going to run some test welds with this guy with the meter on it so you can watch the voltage, and that's going to tell us a lot. So let's start that. All right, so the machine is set for 90 amps now. We're going to weld with it, and I want you to pay attention to the actual closed circuit, so the welding voltage. And you're going to see that with this 1/8 inch rod, depending on what my arc gap is, that the voltage is going to easily spike above 30 volts. Versus a 7018 is going to be in mid to low 20s. So let's start. Now, since I can't weld and watch that screen, you guys are going to see it before I do in a weird kind of way. So you probably saw the voltage was well above 30 volts at times, and then probably high 20s most of the time. You can see that the welder had no issue running it. You could hear it, and you probably saw the arc, the light from the arc. So no issues there. Let's get set up with this little red welder and weld with that, and we're going to watch what happens. All right, so I have the probes for the meter checking our open circuit voltage, and I'm going to chuck a rod up in this and we will get to welding. So it was very, very difficult to keep the rod running because any, even minuscule amount of arc gap, the arc would kill out. And I have a feeling, and again, I'm not watching this while I weld, but I have a feeling this welder cannot, in a closed circuit, output probably more than 30 volts, and it cuts out. So I'm going to review the footage, and then we're going to come back and talk a little bit of some booksmarts. All right, let's do some book learning. The least fun part of my videos, right? But there's a lot to be said, and we can learn a lot from this. So with welding, with stick welding, you have what's called arc voltage. Arc voltage is essentially the voltage that's required to maintain an arc when you're actually welding. Now 6010, like this rod right here, operates at a higher arc voltage than 7018. To understand why that is, let's look at what causes or what's the driving factors behind the voltage. Well, with stick welding, you have your rod here and your molten puddle, which is depicted here. The longer the distance is from the actual tip of the rod that's starting to become molten as you're welding to the plate, the longer this distance is, the higher the voltage is required to keep an arc stabilized and running between these two. Now, if you look here, this is actually the flux on the rod, and the actual rod tip is back up further in here. So you're not looking at this distance, okay? That is not the true arc gap. The true arc gap is from here. So 6010 typically burns off the rod tip a little bit higher. Might be a little bit harder to see if I can get that to focus. There we go. So that's a ball of just like glass on there. When you're actually welding, that's molten or not there. So 6010 tends to have a medium, maybe slightly long distance between this flux and the rod, and that combined, even if you were to hold this flux down here so you have a tighter arc than depicted here, you're still going to require a fair amount of voltage to cross over. Okay, now I got a couple other pictures. This would be like a closer arc gap between the rod and the plate. This is a longer arc gap. Now I find like rods like 6013, if you don't keep pressure on them to keep this flux in the molten pool, that your arc gap can increase and then your rod can kick out on you. You get arc blow really bad because of that. But anyways, we're talking about 6010. So the number one driver of voltage is your arc gap. Now 7018 tends to have a slightly shorter arc gap than 6010, but that isn't the only cause of why the voltage is higher. And the second cause is this flux, so this material that's coated on this rod that either burns off and creates a shielding gas, or it turns to liquid and then gets deposited as slag to protect the metal. That flux turns into a gas in the molten pool area, and that gas does two things. One, it shields that molten puddle from oxygen, because you don't want oxygen getting into that. You'll get porosity and the weld will be poor. It also, in the case of 6010, creates an atmosphere that, how do I put it? It allows for more heat to be generated in here. And what I mean by that is 6010 creates CO2, so like 100% CO2 in the weld pool area. Now, if you ever do MIG welding, you'll know that if you run 100% CO2 versus what they call C25, you're going to notice that on 100% CO2, your arc voltage, or excuse me, your weld's going to run hotter because the arc voltage is going to be higher. Now, you might not know the arc voltage is higher, but you know 100% CO2 seems to make your welds run hotter. Well, the same thing happens with 6010. The CO2 gas in here actually requires more voltage to be supplied by the welder to have the arc cross through that atmosphere. So because of that, 7018, say it needs 24 volts to maintain an arc, 6010 needs 29 to say 32 volts to maintain an arc due to the atmospheric gas in there having essentially more resistance to the flow of electricity. I'll simplify and just say it that way. So that's the two reasons why 6010 will often not work on a welder and 7018 will. It simply comes down to the atmosphere present and then the inherent arc gap built into the rod as it's running that requires higher voltage than what the welder can supply. So now let's talk about why the welder can't supply the voltage. All right, so I was going to do a more in-depth kind of talk about this, but I realized I kind of already did that in another video of mine, and I'll just put a link to the description in there, and I'll just kind of briefly do an overview of this. So the little red Amazon welder, it's pretty simple, and so is even the Miller. They take high voltage, so 240 volts, which is, I mean, higher than the output, and 26 amp, this is what that red welder pulls from the wall, and they convert that power, which is about 6,240 watts, into an output of 30 volts, 140 amps. And I have tested it, the welder does indeed put 140 amps out. The reason that the red welder won't run 6010 is that at say like 90 amps, the most that it will output is around 28 to 29 volts based on what I saw on the video. Now 6010, if you saw the Miller ran it, it needs about 30 to 32 volts to be able to keep the arc lit. So what's going on here is to get that welder's output out of the transformer that's in it, it has to put out under 30 volts. And the reason it has to do that has to do with the windings of the transformer, because yes, it does have a transformer in it. All welders do have a transformer, but it has to do with the winding ratio that they're using to lower the voltage and increase the amperage. In order to get higher voltage, they would have to lose amperage. These two are interrelated to one another when you're talking transformers. Now, if I were to drop the voltage from 30 volts to say 15, I could actually get 280 amps of output out of that machine. Now, that is unrealistic because welding rods don't operate at 15 volts, so that's kind of a problem. So 30 volts is a good place to be, but the problem is that, well, the rod 6010 happens to run over that. So in order to get to run 6010 by changing the winding ratio, we could probably get to say 35 or 40 volts. However, our output would be down to around 100, 110 in the ballpark of that, so much lower output. And that's what it comes down to, is the cheaper welder, and most inverter welders are wound with their transformer and the controller that controls the power input to it to give you a usable 30 volts at a reasonable, say 140 to 200 amp output depending on welder. But going over 30 volts, they can't do because they're not wound for that. And the reason they're not wound, like it makes sense, like why wouldn't you make every welder output 30, say 35 volts? Well, unfortunately, the reason to that has to do with, well, you would need a bigger transformer, and you would also probably need more expensive MOSFETs, IGBTs, etc. that drive the transformer in order to manipulate it to get that kind of output. So it just comes down to, honestly, a lot of it is just simply cost. Now, I'll just say this briefly because I know we're getting into some kind of unrelated information, but what you really have with the Red and the Amazon Special and the Miller welder is you have some manipulation. This is a transformer, this is a rectifier, this is the output. All you're doing is you're feeding a different waveform or a controlled waveform into the transformer to manipulate the output of it, okay? The Miller can manipulate what's feeding a transformer. Likely, instead of doing sine wave, it could feed it a square wave, and it could also change how long, like if you compare this is positive and then 0, if you look at how long it's on positive, it could likely manipulate the length of time and even cut it off and leave no power there. And that can control the output of the transformer. With a big transformer with a lot of windings and having the ratio to where you can really manipulate the output, you just basically have more control over it. You use a bigger transformer and you can still output higher voltage at a reasonable amperage. Now, cheaper welders use much simpler transformers with a lot fewer windings, and their controller that in an inverter style welder that controls what they're feeding a transformer for electricity, for voltage and power, are not as good. And so I guess the gist of it, without going any more technical on it, is just that welders that run 6010 can manipulate the power going to the transformer better, and they likely have bigger, more expensive transformers with more windings that simply give them more options on the ratio for the output, if that makes sense. So that's why cheaper welders won't run 6010, is because they just, in order to get the voltage higher, they would have to drop the amperage to where they don't output anywhere near what you need out of them. All right, onward. Well, in conclusion, now that we covered kind of all the bases of welders and 6010, I thought I would just mention a couple options you have. So if you found out that your welder just flat out won't run 6010, unfortunately, there's not a whole lot you can do about it. I mean, if you take it apart and change the windings on the transformer, you probably could get it to run, but I don't think that's a do-it-yourself type project. But you do have a few options. The first one I'll mention is if your machine will almost run 60-10, so the arc doesn't kick out too much, you know, maybe in a 4-inch weld it kicks out like 2-3 times. If you can find these guys, Hobart branded 60-10, I found that these will actually run pretty decent on that little red Amazon welder. A normal 5P plus rod, that won't run at all, but this, it only kicked out once or twice in a 3-inch weld, so that's far better performance with this than with a normal 60-10. The other option you have, go out and get yourself some 60-11s. These 60-11s operate at a little bit lower of a arc voltage. Because they operate at a lower voltage, most welders will actually run these versus they won't run 60-10s. So try a box of these. I honestly like 60-11. I don't really use it ever, but to me it runs like a little bit more fluid of a pool versus 60-10, but it's very similar in the sense that it will weld through scabbier material, rusty material. It's a little bit easier to weld uphill and overhead with this rod versus 70-18 or 60-13, I find. The only thing is that the main benefit to 60-10 is how fast the puddle will freeze. It allows you to weld like wide gaps and, you know, whatever have you, because you can stack metal on metal because it freezes so fast versus a lot of the other rods, the puddle stays so liquid that it just will drip when you try and fill a large gap. Well, 60-11 doesn't freeze as fast as most 60-10s, so it's not quite as good for poor fit-ups. But again, it does give you a pretty good capability of welding over poor material and poor fit-ups. So it's not, you know, a useless rod. It is good, and all you old school dudes with transformer only welders like Tombstones and stuff, you're used to running this rod anyways. So it's good to have as an option. Now, one thing I did find funny, these 60-10 rods, if you look here, so you can see, I'll flip it upside down so you can see it. 60-10, 60-11. These things literally look almost identical, okay? I almost wonder, because this box says it'll run on AC, I almost wonder if they just slightly modified the 60-11 here and called it a 60-10, and that's why it does a lot better. So anyways, that's kind of what you're looking at. Hopefully your welder will run 60-10, get to learn to use it, you'll love it. It's a little bit hard, it's an ego buster, because if puddle freezes so fast, if you're not smooth, your welds are going to look like junk. I mean, there's no doubt about it, but it's a great rod to have. It gives you a lot of options. So anyways, hopefully you guys learned something. If you got any comments or questions or thoughts, you know where to leave them. Otherwise, I will see you guys around. Thanks.